So let us look at Fourier transforms here. Okay, please remember this formula I'll be using throughout when we try to solve the problems uh, on this. So this is f of alpha 1 by root 2 pi. Okay, so integral minus infinity to infinity. Okay, f of x uh, e to the power of I alpha x dx. Okay. So let us find the Fourier transforms of this. Okay. Let us find the which is f of x. So the function f of x is 0 for x less than or equal to a, and the function is 1 for x uh, is in a and b. Okay, and 0 for x greater than or equal to b. Okay, so let us solve this. As you know, this interval a is minus infinity to plus infinity. So here if I consider this as 0, and this is a and this is b. Okay, so here the function is this. Okay, so we can directly integrate this. So f of alpha, okay, using this formula. So that reduces to 1 by root 2 pi, right? 0. There is for x less than or equal to a, it is 0. Okay. Okay. During this region. Okay. Less than or equal to a. Right. Now, if it is in between a and b, you have a and b. You have 1. F of x is 1. And it is e to the power of I alpha x dx. Again, greater than, it is 0. Here it is 0. Okay. So that's it. That's it. Okay. Now it became simpler to solve. So between A and B on the line. Okay. So if you integrate it, so you get this as 1 by root 2 pi e to the power of alpha is e to the power of mx integration is e to the power of mx by m. So considering that, so e to the power of I alpha x, okay, integrating with respect to x is I alpha a to b. Okay, so this is so write down. So b and a. So this is 1 by root 2 pi e to the power of I alpha b minus e to the power of I alpha a by alpha. Let us multiply and divide by I. So this is I. So I square is minus. So we can further simplify this as this I square. Okay. So if you multiply it, so I square, which is minus 1. So I square is minus 1. So this will be, we have I in the numerator. So I and minus 1. So yeah. So this is your final result. Now let us move further and try to solve this Fourier transforms of this. Okay. Now as you see here, it is uh, for the interval minus infinity, 0, and this is plus infinity, pi. So here the function is sine x. Okay. So using this, yes, using this, yeah, let us find the Fourier transform. F of alpha is 1 by root 2 pi. No, this is 0 to pi. Okay, 0 to pi, and the function is sine x, e to the power of I alpha x dx. Now, if you try to remember, e to the power of ax sine bx integral dx uh, is e to the power of ax by uh, a square plus b square and a sine bx minus b cos bx. Okay, so using this, okay, so I can write this here. If you consider a as I alpha and b as 1, okay, sine bx. Okay, so this will be 1 by root 2 pi. So integration of this. So e to the power of I alpha x, I alpha sine x minus cos x divided by this is a square, which is I square. So I square is, okay, let me write down I alpha whole square, a square plus 1 square. Okay, so 0 to. Now, let us substitute this. Okay, so this will be minus I square, which is minus 1. Okay, so let us substitute the limits here. That would be f of alpha, which is 1 by root 2 pi. Okay, so I can take 1 by 1 minus alpha square common. Okay, I have e to the power of I alpha pi. Okay, I'll be substituting that. And I alpha sine pi minus, this is cos pi. minus e to the power of 0, which is 1. Okay. Um, I alpha sine 0 minus cos 0. Okay. You close it entirely. So cos n pi, which is minus 1 to the power of n, sine n pi is 0. Okay. So since pi, this is 0, this goes to 0, and this is minus 1. Yeah. This is 0, and the cos 0 is 1. This is 1. So let us substitute it. So this is 1 by root 2 pi 1 by 1 minus alpha square e to the power of I alpha pi. This is 0 minus of minus plus 1 minus this is 0 and this is minus 1. So I can take this here. So this will be, and I can e to the power of ix is cos x plus I sine x. So e to the power of I alpha pi, which is cos alpha pi plus I sine alpha pi. Okay. So let me write down. So I can take this, darling. So this is plus 1 and by root 2 pi plus 1 minus alpha square. As I said, this is cos alpha pi plus I sine alpha pi plus 1. Okay. Or I can take the imaginary and the real part. Okay. So this will be 1 plus cos alpha pi uh, divided by, this is root 2 pi 1 minus alpha square I into sine alpha pi divided by uh, root 2 pi and 1 minus alpha square. Okay. So that's it. So let us have a look at another problem to find the Fourier transform of f of x, which is e to the power of minus x square by 2. E to the power of minus x square by 2. Okay. So using the formula f of alpha, so 1 by root 2 pi integral minus infinity to infinity f of x is e to the power of minus x square by 2 into e to the power of I alpha x dx. Okay, so let us keep the powers minus x square by 2 and this is plus I alpha. Okay, so let us try to simplify this. Yeah. I'll put this as x square. X square, I'll keep that positive, minus 2 I alpha x. Okay, so taking 1 by 2 outside. Okay, so if you look at this, I can add alpha square and subtract alpha square. So I can combine this both as x minus I alpha whole square and this is plus, okay, alpha square. Yeah, combine this. So this results to 1 by root 2 pi. This is minus infinity to infinity. So I've taken minus half outside. So in the power, I have x minus I alpha whole square plus alpha square. Okay, this is dx. Now, if I take multiply this again, I can take the constant terms outside. So this results to e to the power of minus alpha square by 2 divided by square root of 2 pi. This is minus infinity to infinity e to the power of minus half into x minus I alpha whole square dx. Okay. Now, let me consider this y as x minus I alpha by root 2. So your dy will be 1 by root 2 into dx. Okay, so since alpha is a constant and you want dx, dx is root 2 dy. So there is no change in the um, the variables here. So let us substitute it. Yeah. So as I said, so this will be e to the power of minus alpha square by 2 divided by root 2 pi. This is minus infinity to infinity e to the power of minus y square into root 2 into dy. Okay. So further, this is done. So I can cancel this out, or I can write this finally e to the power of minus alpha square by 2 by root pi minus infinity to infinity e to the power of minus y square dy. Now, please remember this as it is 0 to a or 0 to infinity. We take 0 to infinity e to the power of minus x square dx is root pi by 2. Okay. So this I can write this as since it is I'll use this minus a to a also f of x dx as 2 uh, 0 to a f of x dx. I use this also. So this is 2 times e to the power minus alpha square by 2 divided by root pi and 0 to infinity e to the power minus y square dy. Okay, and this result is root pi by 2. So okay, minus alpha square by 2, and this is root pi by 2. So as you can see, uh, this f of alpha is e to the power of minus alpha square by 2. Okay, so I want to conclude saying that if f of x is e to the power of minus x square by 2, right? And the Fourier transform of f of x is, that is f of alpha, which is e to the power of minus alpha square by 2. So it is a self-reciprocal. Okay. So also note that if f of x, you have e to the power of minus a square x square. Okay. And then where a is a real constant. Okay. Then f of alpha will be 1 by a root 2 e to the power of minus alpha by 2a whole square.